Hello, everyone. Good day. So, I welcome you to another live discussion about Earth science. So, this is our fifth session. So, last time we have discussed the things about our own universe and the solar system. Okay, we have learned about the different underlying theories that comprises both. Okay, so from the bigger picture, let's now go to our own planet Earth. Okay, let's go fly to our own planet, and we will be dealing with the Earth's spheres, its structures, and also its interactions. Okay, so I have an image here. Okay, so this is the image of the avatar. Okay, I don't know if you know Ang. So Ang here is actually the avatar on the cartoon series. So on this picture, on this image, we can see that he is holding the Earth. Okay, so why is he holding the Earth? It is because that as the avatar, um, he is protecting, okay, protecting the planet, making it such that it won't be in disarray. Because we all know that our Earth is the only planet in the solar system that is capable of supporting life. Okay, as we know sa anong in our elementary years, we know that the Earth is actually called the blue planet, and that blue planet is the symbolized that the Earth has life. Okay, that it can support life. Okay, so complex and brilliant combinations of gases, composition and structure of the Earth are some of the reasons why it can sustain life. That it is because Earth as a planet is a very complex place. Okay, so we will now go over to the things that we know about our Earth. Okay, so in our solar system, the Earth is the fifth largest of the planets in the solar system. It is smaller than the four gas giants and larger than the three other rocky planets. Okay, so based on its size, the our Earth is actually on the Goldilocks zone, meaning um, it is in between the solar system that can uh, primarily support everything or that can support life itself. Okay, so in this image, let's go back to Ang. We have these key elements here. Okay, so we have our own Earth that is protected by Ang, the avatar, and we can have an analogy because this figure here resembles us humans because we are the one who is protecting the planet. Or on the negative side, we are actually destroying it. Okay, so we have these key elements. We have this air, water, fire or life, and last one we have the earth. These key elements actually represents four spheres that resembles or that are the components of the earth itself. So before we go into the four spheres, let's now discuss how did the earth came to be. So how was it named? So I have this. So the name Earth is at least 1,000 years old. All of the planets except for Earth were named after the Greeks and the Roman gods and goddesses. However, the name Earth is a Germanic word which simply means the ground. Okay, everything that we step into, the house that is built from the ground, that is the earth. Okay, so in the Greeks, it is equivalent to the term Gaia or Terra or Terra mater, and it means that it is called the Mother Earth. Its Roman equivalent is we have this Tellus or Tellius. That means fertile soil, meaning it can support life. So the Earth consists of four distinct yet connected spheres. So we have the key elements. And these processes, all of these processes on Earth are driven by these spheres, which we will describe individually. And so that we will know how is it being connected with one another. So we have this. So these are the key elements. Again, we have the air, water, land, and life. So these key elements comprises of what is Earth today, and even in the past, and also in the future. And because of these key elements, our Earth won't be the Earth as we see it today. So now we will be talking mainly about these following spheres. So we have this. We have the air, water, land, and life, which are these spheres. So one of which, the air, is part of the, or is it within the atmosphere. The land talks about the geosphere. Hydrosphere, on the other hand, talks about the water. And lastly, the life talks about the biosphere. Okay, so let's define these spheres one by one. So here are some basic definitions of of the four spheres. So we have the atmosphere. It is the part of the Earth system that includes the mixture of gases that surrounds the planets. So, mainly talking the oxygen, the carbon dioxide, the nitrogen, every gaseous elements that is found on the atmosphere that is part on that sphere itself. In the geosphere, it is the part of which includes the internal layers of the Earth. So, we have these three major components of the geosphere. We have the crust, mantle, and the core. And later on, we will know the subdivisions of these major divisions. Third is we have the hydrosphere. So on the other hand, it is the part on which talks about the planet's water. So everything that you can see na merong tubig, that means that it is part of the hydrosphere itself. And also the groundwater, ice, salt water that is found in the seas and on our oceans, and also water vapor. It is part on the hydrosphere. Lastly, we have the biosphere. So from the word bio meaning life, so it includes all of the living things, the plants, and other organisms living on our planet. All right. So let's discover these spheres one by one. Let's start with the geosphere. So when we hear the word geosphere, we automatically image the layers of the earth, right? So that is correct. So the geosphere, by its definition, it is the solid inorganic earth, including Earth's surface and layers of its interior. Okay, so it describes all of the rocks, minerals, and ground that are found on and inside the Earth. It is divided into three main parts: the crust, mantle, and the core. So it includes everything from the mountains on the surface, as well as of the liquid rock that is found in the mantle below us, and the minerals and metals of the outer and inner core. So all of those things are components of the geosphere itself. So the Earth is actually composed of nested shells that are classified according to its chemical and mechanical or physical characteristics. So we will have an analogy. Um, for example, I am holding a boiled egg, and that boiled egg itself resembles the geosphere of the Earth, for which the shell is actually the crust, the white part of the egg or the boiled egg is the mantle, and that yolk, the yellow portion, resembles the core. So we have this. Let's try to distinguish the layers one by one. So, with respect to the geosphere, we suddenly remember Toughbay Fong from the Avatar, diba? So, he is the one of which is a character from the series that has the power to move or hurl rocks away from its enemies. So, this time, let's recall the internal layers of the Earth, or basically its inner structure. So we have this. So on the image, we can see that the geosphere is part of the Earth that is from the surface sa ibabaw ng planeta mismo up until to its innermost layer, and that is the inner core. Okay, so moreover, each layer of structure are composed again, di ba, from the three major components, but it is subdivided into two for each major layer. So we have the core. Let's start from the innermost. then going to the surface. So we have the core. It is composed by two major layers or major subdivisions. We have the inner and the outer. Next is we have the mantle that is primarily divided by the lower mantle and the upper mantle itself. And lastly, we have the lithosphere. Okay, that is in the section uh, part of the crust mismo. Okay, so as you can see, everything is subdivided and we have its what we call boundaries. So I have this arrow here. Okay, I hope that you've remembered this boundary because it was taught on your elementary days. So on this portion, this is the boundary between the crust and the mantle, and it is called the moho or the Mohorovičić discontinuity. Okay, so same as with this boundary, we have also this boundary located here in this portion. So in between the core and the mantle, and we call that the Gutenberg discontinuity. So the Earth, actually, our planet, is made up of different layers. Okay, so the very thin, brittle crust, we have the first one on this portion. So as you can see, this brown color here, it is the thinnest among the layers. Next is the mantle. This is the biggest portion of the internal layers of the Earth. And lastly, we have the core. We have the outer and the inner. So based from this image, we can conclude that it is subdivided into components, and it is because it has its different compositions. So and also it has its different characteristics. So let's discuss now the different characteristics on which it is being divided. So we have this its composition, its chemical composition, and its mechanical characteristics, or what we call the physical characteristics of the internal layers of the Earth. So we have this on the left portion, its composition. So as you can see, the crust and the mantle are made up of primarily silica, but it has its minor components that we can distinguish. In the crust, we can see or observe that it has light metallic elements, meaning of light, for which the color is lighter in color compared to the mantle's composition because it has iron and magnesium. So that means as you go lower to the internal layers of the earth, the temperature will rise and also the pressure will rise, making it that the uh, rocks found below will be darker in color as you go down. Then, because of pressure and temperature, eventually it will form into iron and nickel, and that comprises the core. And we have these mechanical characteristics. The core itself is divided into two, and the outer core is primarily liquid, and the inner core is primarily solid. So, making it that the core resembles two phases of matter. So why is it liquid on the outer core and why is it solid in the inner core? So we can see that because of high temperature and the inner core is located on the innermost, making it such that it is being pressurized. Thus, it making it it will be solidified. Unlike the liquid outer core that is under high temperature, that makes it being liquefied. And the core generates also the magnetic field that protects us or acts like a barrier in any form of extra uh, terrestrial object that will come on the Earth's atmosphere. So this is the reason why the Earth has its own magnetic field. That is because of the core itself. So as we go up, you have the mesosphere. So the mantle is actually historically known as the mesosphere. And the mantle is solid. Okay? So again, the mantle is solid in nature. Above that portion, we can find the asthenosphere. So in this portion, it is actually plastic, meaning it is solid yet nearly liquid. So if you can image a slime, that is an example of a plastic phase of material. So above that, we can find the lithosphere. And that lithosphere is actually a brittle solid portion of the earth. And it is the thinnest layer. So this lithosphere is actually uh, is part of the crust. So making it that it breaks down into several plates. So recall your um, topics on plate tectonics. Okay, you remember the Pangea? It is the supercontinent that was once uh, found on the planet itself until such it is broken down into several pieces, and that composes the seven continents as of today. So, if we can observe, these plates are actually floating on this plastic asthenosphere. So, making it that um, there will be movements of which this upper layer here, the lithosphere, can be broken down into pieces. Okay, so that is an analogy of how is it being connected with the plate tectonics theory. So let's try to have a recap. So these are the compositions. So again, the geosphere is the part that is mostly solid. Why mostly? Because the outer core and the asthenosphere is not uh, a solid part portion of the Earth. Okay, so it is the geosphere again, a mostly solid, rocky part of the Earth that composes of the crust, mantle, and the core. In the crust, it is the thin outermost layer that is made of silica minerals that merong dalawang types of crust. So we have the oceanic and the continental crust. So we can distinguish this the both because it has its own thickness. So the continental crust is actually thicker compared to the oceanic crust. And we have these mnemonics here. We have the SIMA and we have the Cl. So this is the chemical components that we can find on both crust. So SIMA meaning silicate and magnesium because it is found in the deeper portion, and Cl silicon and aluminum because it is found on the upper portion. So making it that the oceanic crust is found below, or the continental crust that is found above it. So if the two crusts will converge, the one that will sink or actually subduct is actually the oceanic crust because of density differences. Next, we have the mantle. So the mantle is made of very slow flowing solid rock consisting of again silicate minerals but are denser than the silicates in the crust. And it resembles 2,100 kilometers thick. Okay. So if we compare it to the crust and to the core, uh it has the larger volume compared to the other two. Lastly, we have the core. It is the Earth's central part that is made of very dense iron and nickel. So we can have a mnemonics here. So we have the Fe. So the core is actually about 7,100 kilometers wide and 3,500 kilometers in radius. And this is the densest center or the layer of the Earth and the hottest part portion. It is made of almost entirely of iron and nickel. So the inner core and the outer core, again, the inner core is solid, the outer core is liquid. So the core is responsible for the planet's magnetic field, which helps to deflect harmful charged particles that comes from the sun. And it is in this layer that we can find the movement of metallic ion that generates the magnetic field itself. So we can image that the inner core also is a hot, dense ball of iron. So meaning that the temperature of this inner core is far above the melting point. And despite its higher temperature, the iron in the inner core is solid due to the immense pressure that exists in the center of the planet. So those are the internal layers of the Earth that is found on the geosphere. So now we will talk more on the roles of the geosphere. What does or how does it contribute to the Earth system as a whole? So we have these roles of the geosphere. So one of which is it is a contributor of particulate matter and atmospheric gases to the atmosphere. Also, it is a contributor of salts to the ocean to maintain its salinity level. So without this particulate matters, we cannot create clouds because the this dust is actually a catalyst in forming clouds. And also, on the other hand, it is an ultimate source of nutrients for all living things. So without the land portion or without the soil, we cannot plant. If we cannot plant, we don't have food. If we don't have if we don't have food, the earth itself will be just a uh, like for example, it will just look like the planet Mars. So next is movement of plates produces barriers that aid in isolation of population of organisms. So therefore, because of these barriers that can be produced in the geosphere, because the plates are actually moving, it influences evolution. So, like for example, two organisms that is found on different continents, each of which has its own environment, thus can influence the evolution of the both organisms. So here is a sketch of the whole structure of the Earth. So the geosphere is very important since it is a contributor of everything. It balances everything from the surface of the Earth down to its very inner core. Okay, so everything on this sketch, you can actually pause this so that you can view everything, because in here in this image it is actually summarized, so we can see every layer and also its defining characteristics and properties. Okay, so we are done with the geosphere. Let's go on with the hydrosphere. So we have the hydrosphere. So our planet has been called the blue planet, as we remember in our elementary years. So it is due to the abundant water on the surface of the Earth. And actually, over 71% of the surface area of the Earth is covered by water. So imagine how vast the liquid water is that is found on the Earth. All the Earth's waters, solid or in liquid form, those that are contained in the colder regions, in the glaciers, the rocks, the soil, and the air, comprises the Earth's hydrosphere. Okay? So, if we define by its definition, the hydrosphere is the part of the Earth that is liquid water. And about 97% of Earth's water exists as salt water, while the remaining 3% is fresh water. So we have two types of water. We have the salt water and we have the fresh water. The fresh water, we have some examples. We have glaciers, lakes, rivers that is found on the inland. Okay, most of them can be found inland, but the vast part is can be found on the seas on our oceans that exist as the salt water. So we have this. Water on Earth is constantly moving. So how does it moves, or uh, why does water moves from this portion to the other portion of the Earth? So it is primarily because of the what we call water cycle or the hydrologic cycle. So as we remember, we have the sun evaporates the water on the oceans, thus making it to form into water vapor, and that water vapor condenses to form clouds, and that clouds eventually will precipitate, and the water will fall down due to gravity to the land surface. And again, everything on the every water on the surface on the land surface will actually go uh, to the open sea. So it works like a cycle. Okay, it will repeat again and again. So it even moves into and out of living things. So syempre, we drink water and we excrete water because it is a part of our body, and our bodies actually consists of mainly of water itself. So recall, we have the water cycle here. So with the processes, we have the evaporation. It will go into the atmosphere. Then it will be precipitated, making it that the water itself will go down or will fall down. Then it will run off and it will eventually go to the open seas. So water on Earth is continuously moving. It is endlessly circulating through the hydrologic cycle. So we have the two types of water. We have the surface and the groundwater. It composes with the 3% fresh water on Earth and 97% of the salt water. We have also this what we call the frozen water. So this is another or a part of the hydrosphere that is named the cryosphere. So this sphere is actually made up of all of the frozen water on Earth. Thus, we can see snow, ice, sea ice, glaciers, ice shelves, icebergs, and permafrost. All of these things are actually part of this cryosphere. So, what are now the roles of the hydrosphere? So, the hydrosphere represents water itself. Thus, one, it actually moderates climate. It is a vital part of the earth because it is the one who balances the climate, the weather also. So it transfers heat and energy from one area or from one location to another or from one organism to another. And also, water is essential in many of the Earth's processes, from mineral formation. Without water, minerals cannot be formed because there are some minerals that are formed because of water. Like for example, salt. Without water, we cannot form or the salt cannot be formed. Or if without the hydrologic cycle, salt cannot be formed into its solid state. And also some of the processes. For in fact, we have weathering and erosion. Without this water as an agent, it cannot transfer. It actually can transfer a material from a desired location. So this is how vital the hydrosphere is. Without water, everything will be stagnant. It will be still in its place because this water is actually a ground or an agent of which it can move everything because it has power to do such. So we have done with the hydrosphere. Let's go to the next sphere. We have the atmosphere. So this is the sphere that envelops the air that surrounds the earth and pulled by the gravitational force of the planet. So it is actually a mixture of invisible gases that surrounds Earth. So as we remember, nitrogen is 78%, oxygen is 21%, and 1% represents the other gases. We have argon, carbon dioxide, carbon monoxide, ozone, hydrogen, helium, and other inert gases. That makes up the remaining 1%. Earth's atmosphere provides oxygen for living things, and also it protects Earth's inhabitants from harmful radiation from the sun. It helps also to keep the planet at a temperature suitable for life since it traps some energy from the sun, which helps the planet to keep it warm enough for living things to survive and multiply. Some gases also of the atmosphere absorb or reflect harmful ultraviolet rays, thus making it a barrier that protects Earth and its living organisms. Also, one thing, it also causes space debris to burn up before reaching Earth's surface that can cause harm. So basically, The atmosphere is a defense barrier mechanism that protects the Earth from visitors outside. So let's go to the layers of the atmosphere. So we recall this because we have done this. You have discussed this actually in your elementary years. So again, we have these layers. First is we have the troposphere. Tropo meaning it is found on the tropics or mainly in the surface. Okay, so from 0 to 10 kilometers, it constitutes the climate system and the weather also that maintains the Earth's conditions for life. This troposphere is actually the lowest layer, and it means that uh, again from the tropo meaning uh, change. Thus, it is the part of the Earth when when there is a change in the environment from the weather system and or the climate system. This is the part of the earth on which the air is closest, and this is the area on which we are living. And also weather is formed on this area. Airplanes and other aircrafts can be found also on this layer. Up above the troposphere, we have the stratosphere. From the word strato, meaning layer or level. So this layer lies above the Earth's weather system and mostly changes very little. It contains the ozone or what we call the O3, which shields us from the sun's ultraviolet radiation or the UV rays. So, except where it's been harmed by man-made chemicals. So, as we all know, we have climate change because of the chlorofluorocarbons. And because of that, the ozone is actually depleting every now and then. Above the stratosphere, we can find the mesosphere. It is the coldest layer of the atmosphere. And in this portion, meteorites break apart. And this is the location on where we can find diffused atmospheric compounds that acts like a layer of that envelopes this mesosphere on this layer. In this layer, we can find also the aurora or what we call the aurora borealis and the aurora aureolis. Above the mesosphere, we can find the thermosphere. So this is the next layer that lies above the mesosphere. It is 5 times as deep as all other layers combined, and it is a very hot layer since the air on this portion is limited. So meaning the radiation from the sun can actually go through on this area. So it holds up to at least 2000 degrees Celsius because as you go farther away from the ground, the atmosphere will become or the air will become thinner. And because of that, the radiation can put through, go through to this layer itself. Lastly, we have the exosphere. This is the outermost portion of the atmosphere. From the word exo, meaning outside. So this is the part where satellites circle the Earth, and this is beyond 300 miles above the surface of the planet. So let's go to the roles of the atmosphere. So like the geosphere and hydrosphere, the atmosphere serves as a barrier that protects the Earth from outside visitors. It acts like a shield that disintegrates every object that is coming inside of the planet. One thing is that it contains the gases that living things need for survival. For example, carbon dioxide for photosynthesis for the plants, and oxygen for respiration for the living things. It also transfers heat that is coming from the sun, and the ozone layer of the stratosphere that is found on the stratosphere protects living things from excess harmful ultraviolet radiation. Lastly, it plays a part in weathering and erosion on the surface of the earth because of the wind system itself or the wind itself. The last sphere, we have the biosphere. The least we don't forget is the part on which life is located. So we have the biosphere. So it is this sphere that we can find all forms of life that is existing on our planet. Since life exists in air, in water, and on the ground, its boundaries overlap around this sphere. So everything that is part on the biosphere resembles the other three spheres because life can be found everywhere on the planet. Again, so we have the biosphere. So the biosphere is sometimes thought of as one large ecosystem, meaning it is a complex community of living and non-living things functioning as a single unit. So we can have an analogy here. For example, you are doing a group activity, different heads, but working on one goal. So same as with the Earth, many processes and many interactions, but working as a whole. So thus it includes all organisms on Earth as well as the environments in which they live. Most organisms live within a few meters of Earth's surface, but some exist deep beneath the ocean surface, and others live high atop the Earth's mountains. All of the Earth's life forms require interaction with at least one of the other systems for them to survive. So the biosphere, why is it very important? It's because that the biosphere aids in weathering and in it also is an important sink for certain elements, especially carbon. It also mediates the formation of some minerals and processes like photosynthesis. The plants is part of the biosphere. It is living. Thus it maintains the oxygen content of the atmosphere for the living things to survive. In the smallest sense, actually this biosphere can be also called as our home. So this is the part that we are living in. So in this complex system, the earth is actually a work as one. So the earth can be considered as a system. So with all these spheres that interact with our planet, we can conclude that our own planet is a complex system made of living and non-living things and matter and energy that is continuously cycling through the smaller systems. So we shall define this. What is a system? So a system is a group of related objects or parts that work together to form a whole. So again, the Earth system is composed of all the matter, energy, and the processes within Earth's boundary, which means it cannot stand alone and it needs the other sphere to make the others work. So in short, all of these spheres are interconnected and it acts like a clockwork. So let's try to relate it. So for a further visualization. So this is an activity for you guys. So we have this image. So why do you think Earth as a system works like a clockwork? What will happen if one gear will not work? So like for example, if we remove the atmosphere, if we remove the hydrosphere, if we remove the processes that is within those spheres, what will be the consequences? Okay? You can actually answer this after this discussion. You can actually research these things because it is actually nandito na yon, makikita na natin ito sa our on the outside or the outside world. Okay, so we can actually see it from the news media outlets that there are actually natural disasters that are happening because of the complications of the different sphere interactions. So I will let you research for this one, and we will see or we will meet with the next discussion, and we will talk about how is it being connected, or mainly how is it interacting, how is each sphere interacts with the other spheres. So thank you for listening, and see you to our next discussion. Thank you for listening.